turns out to be I'm getting 32.85. So my test statistic ends up being negative 60 divided by this thing, 32.85, and I get a test statistic of negative 1.826. That is my test statistic. Alright, so to get the p-value, what do I do? I look up my test statistic in the t-table. We have a question.
Does that number doesn't matter? I know it doesn't matter for this. It matters for this.
Yeah, so when you go to your t-table, you only have positive values. So what do we do?
Just reverse that negative.
Yeah, you just ignore the negative. And keep going on. Find your tail area. So we look this up in the t-table to get our p-value. How many degrees of freedom do I use? I'm going to do 25 minus 1, which gives me 24 degrees of freedom. And I look that up in the table, and I do see 24 degrees of freedom. Okay? And I'm looking up 1.826. So for 24 degrees of freedom, I have 1.711, and I have 2.064, and 1.826 fits in between. Okay, 1.711 corresponds to area 0.050, and 2.064 corresponds to 0.025. So my tail is going to be in between these two values. Alright? So whatever my tail is, it's less than 0.05, but more than 0.025. Alright? Do I leave my tail area as is, or do I double it to get my p-value?
Leave it as is.
Leave it as is because my alternative has a not equal sign. So this means I have a one-sided test. So I leave my tail area as is. And so I get my p-value. Is between 0.05 and 0.025. Number 32 says, perform a hypothesis test, one-sided hypothesis test with alpha equal to 0.05. What conclusion do you make? So is my p-value bigger or smaller than 0.05? Right here it says 0.05 is greater than p-value. So my p-value is less than 0.05. So that means I reject the null hypothesis. Rejecting the null hypothesis means caffeine does or does not improve reaction time. It does. Okay, we have evidence. Caffeine improves reaction time. And if our previous conclusion was wrong, what kind of error did we make? So we just chose to do what? We just chose to reject the null hypothesis. If that was a mistake,
Type 1.
type 1 error. So if rejecting H0 was wrong, that is a type 1 error. wanna just power through this and end early, or do you wanna take a break? Just power through.
Take 5.
You wanna take 5 minutes?
No, I'll just go. It's fine.
Okay. Yeah. If you gotta excuse yourself, you excuse yourself, no problem. But we'll just power through it, and then we'll try to end class a little early then. Probably not by a whole lot, but
How many questions are there total?
on the practice,
Yeah.
58. We're at number 34. Yeah.
So you know how you wrote type 1 for both of the previous questions? Will we ever have type 2?
Yeah. What is a type 2 error?
Not a type 1.
So type 1 is you've rejected the null,
Okay.
and that turned out to be a mistake. Type 2 is you didn't reject the null, and that turned out to be a mistake.
Okay. Is that
Okay.
in the study guide?
Huh?
Is that in the study guide?
Yes.
Okay.
Or I don't know. Let me see. I think so.
Okay,
At
so I'll just like.
It's at the very bottom of the second page, I think.
Professor, are you putting this after the review one?
I anticipate doing that. Okay. There's a chance sometimes my camera breaks and it corrupts the video files and that happens. Okay. Number 34 through 39 says, in a certain city, a study was conducted to see if the police department had a different proportion of minority employees than the fire department. Researchers randomly selected 200 employees from both the police and fire departments and took note of whether the employee was a minority or not. Group 1, 200 random police department employees, 80 of them were minorities. Group 2, 200 random fire department employees, 50 of them were minorities. Is this evidence that the two departments have different proportions of minorities? Okay. Most important thing, just we got one sample or two samples means of proportions. Two samples, proportions. Good. Number 34 says, write the appropriate hypotheses. So, you guys remember? Null hypothesis, when you have two sample proportions, is P1 minus P2 equals 0. The alternative hypothesis, do we have a one-sided or two-sided test? What does it ask? It says, is this evidence that the two departments have different proportions of minorities? So it's a two-sided test. We're going to use a not equal sign here. Okay. Number 34 says, for this hypothesis test, what is the value of p hats? Okay, so before we do that, let's write down the data that we have. Alright, so we have group 1, which is the police, and group 2, which is the fire department. And our N1 for the police is 200, and the number of minorities was 80.
This is a categorical data, right?
Yeah, this is categorical data, exactly. So we have N1 is 200 and X1 is 80, N2 is 200 and X2 is 50. So my proportions, P1 hat, 80 divided by 200, we have a proportion of 40%. P2 hat, 50 divided by 200, 0.25. Number 35 says, what is P hat? So the overall P hat is going to be X1 plus X2 over the quantity n1 plus n2. Okay. Again, all of this stuff is detailed out in the study guide. So, x1 is 80 plus x2, which is 50, and this is over 200 plus 200. So I have 130 over 400. I don't know what that is. 0.325. Okay. 36 asks, what is the test statistic? So test statistic takes your observed p1 hat minus p2 hat, technically minus 0 divided by the standard error. This is going to be our test statistic. So p1 hat is 0.40 and p2 hat is 0.25, and my standard error p hat times 1 minus p hat over 1 over n1 plus 1 over n2. Fill in all of these numbers here. So p hat 0.325 times 1 minus 0.325, 1 over 200 plus 1 over 200. Entire thing square root. When I do that, I get 0.04684. That's my standard error, and I'm going to plug that in up here. So my z-score is 0.15 divided by 0.04684, and I get a z-score, if I round off to 2 spaces, equal to 3.20. So number 36, our test statistic is 3.20. Number 37 says, what is the p-value? Okay, so what do I do to get my p-value? My z-score is 3.2, so I'm going to look up 3.2 in the z-table, and what do I find?
3.20.
Yeah, 3.20 in the z-table.
0.9993.
So look up 3.20 in z-table, and we get 0.9993. Okay, is that my tail area? No. What do I do to get my tail area? I have to subtract this from 1. So my tail area is equal to 1 minus 0.9993. My tail area is 0.0007. Alright. So is that my p-value, or do I have to do something else?
You have to multiply
I
it by
have to
2.
double it because I got a not equal sign. Not equal sign, so I double my tail area, and so my p-value is equal to 2 times that tail area. So my p-value is 0.0014. That's my p-value. It did not specify what alpha to use. So if it doesn't specify, we assume alpha is 0.05, and my p-value is less than 0.05. So that means we reject the null hypothesis, and we say we have evidence that there is a different proportion of minority employees. 39 asks, in the context of this problem, what does it mean to commit a type 1 error? So 39 says, what does it mean to commit a type 1 error? That means a type 1 error means the null hypothesis is actually true, but we've rejected it. So that means, in our case, if the null hypothesis is true, what does that mean? It means the proportion of minority employees
Equal to.
at the fire department and police departments are the same.
Yeah.
Okay? So type 1 error means the fire department and police department and fire department have the same proportion of minority employees. But our conclusion is we believe they do not. But we conclude that they are different. It's not too terrible, right?
It's awesome.
Okay. Well, everything seems easy when I do it on the board. Huh? Yes. Okay. So, this week as you study, I would say, try to do the problems as much as you can by yourself without any outside help. And if you want to go beyond that, try making up your own problems. Read the, see the examples that I have given you in the practice final, and see if you can make up your own problems. Okay. And let's solve those. Alright, so let's do 40 through 44. It says potatoes are sold at the grocery store in 5-pound bags. You decide to weigh a random selection of 10 different bags. You find that the average weight of these bags is 5.2 pounds. The standard deviation is 0.3. Is this evidence that the bags at the grocery store have a mean weight different from 5 pounds? The following questions refer to a 95% confidence interval. Okay. 1 sample or 2 samples, means or proportions?
One sample means.
1 sample mean. Alright. And we're making a confidence interval. Okay. So it says, how many degrees of freedom do we have in this problem? Degrees of freedom is equal to n minus 1. So what is our n? 10 bags of potatoes. So our degrees of freedom is 9. Okay, let's write down the data that we have. N is equal to 10. X bar is equal to 5.2, and my standard deviation is 0.3. Okay, what's the center of the interval? So again, if you forget any of this stuff, you can check the study guide. Center of the interval for 1 sample mean is the sample mean, x bar. So in our case, the center of the interval is x bar, which would be 5.2. What is the standard error? It asks, number 42. What's the standard error? S over the square root of n. But if you had forgotten, you can always check on here, and it says, oops, standard error for one sample mean is S over the square root of n. So we have 0.3 divided by the square root of 10, and that gives us some number. 0.0949. 43, what is the resulting 95% confidence interval? So we are going to do 5.2 plus or minus t star times my standard error, which is 0.0949. The t star comes from our t table, and for 95% confidence and 9 degrees of freedom, the value I'm using is 2.262. I think that's the second time we've used 2.262. So I get 5.2 plus or minus whatever this turns out to be. .215 or 0.2147. So I get 5.2 minus this, and I get 4. To 5.4147. Alright, what conclusion do we make? So the question says, is this evidence that the bags at the grocery store have a mean weight different from 5 pounds? So 44, do we have evidence that it's different from 5? No, because 5 is within my interval. It's barely within my interval, but it is. Okay? So 5 is within the interval. So we do not have evidence that the mean weight is different. What's that?
Oh, no.
You just excited? How can you not be excited, right? It's the best.
It's gonna be a phenomenal test.
It'll be the best. The best. Alright. Is this good? Number 44? Okay. Look at the next one. This is the last one where we do computation. And after this, it's all easy peasy, and then we'll be done. I'll happily answer any questions that you guys have also. Alright, 45 to 49. It says a fair die should land showing the number 4 1/6 of the time. You roll a die 100 times and count how many times it lands as 4. And it lands as the number 4 20 times. Is this evidence that the proportion it lands 4 is different from 1/6? You guys want to try doing this one on your own? Or you just
Well, is different.
Okay, alright, I'll do this for you guys, just to stay in tradition, and you guys, it is your responsibility this week to do it, so. I mean, to study for the final exam, okay? Of course.
I'm gonna miss you so much.
You're gonna miss it? Oh, that's very kind, that's very kind. Alright, so let's do this. One sample or two samples, means or proportions?
One sample.
One
proportion.
sample proportion, great. Hello. Alright, one sample proportion. What are the appropriate hypotheses? When you're dealing with one sample proportion, our null has what symbol in it?
Equal. No.
Okay, there is an equal, but are we using mu, p?
Mu.
One sample proportion p, no hat, right? Okay, and it should be equal to? Should be equal to 1/6, okay? Now some of you guys don't like using fractions, so you can also write p is equal to 0.1667, that's fine. But 1/6 is a fraction, and that's also a proportion, right? Alright, and the alternative, it says, is this evidence that the proportion it lands on 4 is different from 1/6? So we use not equal to. Okay, so what is the sample proportion? This is p hat, and that is 20 out of 100.2. Alright, and 47 is written in a funny way, okay, but the standard deviation of the sampling distribution is another way of saying the standard error. Okay, so 47 is essentially asking what is the standard error. So what is our standard error?
Let's refer to our chart.
Yeah, we'll look at our study guide, okay? We're doing hypothesis tests. So this is all confidence interval stuff. The standard error is square root of p times 1 minus p over n. Okay? And it says use the p from the null hypothesis. So I'm going to use 1/6 times 1 minus 1/6 divided by n, which was 100. Okay, or you can plug in the decimals if you prefer. And I get 0.03727. Yeah, I put 5 decimals there, but if you put 4, that's also fine. Okay. Not a huge difference. So what is the test statistic? It's number 48. Okay, if we do observed minus the null over the standard error, the observed proportion that we got is our p hat, 0.2, minus the value in the null, which is